Okay, so now for the assignment from this module. The first thing we're going to do is use the TV adjust inspect model that we developed during the first two videos, and we want to do two things. The first thing we want to do is fix the issue where TVs are adjusted the fourth time, or adjusted and inspected, even though that we know they'll be rejected. So if we pull back the model, what we see is that we have our rejection criteria here is that num adjust equal to 4, and so we know that they will go after the third failure, they will fail again and come back through and be adjusted and inspected, only to be sent to bad here. So what we'd like to do is fix this to where they are immediately rejected after they fail the third time. And so I'm giving you a hint here, and the hint is to start by inserting a basic node. So what I'm telling you to do to start with is to delete this path, insert a basic node, and then go have two paths from the transfer node to the basic node to adjust. So we're inserting a basic node here to give us an additional decision point. For the second task, what I'd like for you to do for this model is to create a reference property for the maximum number of adjustments allowed and develop an experiment that compares configurations with this value of 1, 2, 3, 4, 5, and 100. And so if you recall our experiment, we saw that we have the two utilizations, time in system, number in system, along with the average and maximum number of adjustments. And so for the assignment, what I'd like for you to do is to make this maximum number of adjustments be a reference property, and so it will therefore show up as a control. And so you can select either of the two processing times to use. You don't have to do the full experiment with both processing times. All I want to see is the control for the number of adjustments being 1, 2, 3, 4, 5, and finally 100. For the second assignment, we'll use the dynamic routing model that we did from the third video. And so the first thing I want you to do is create an experiment and have 25 replications, run length for each replication of 500 hours with a 250-hour warm-up. And I want you to set up responses for the 3 server utilizations, the entity timing system, and the entity numbering system. And using this model, I want you to compare the 5 different configurations given below. So the first comparison, or the first configuration, uses the probabilistic routing and the proportion that we would get if we use the expected processing rates. The second configuration uses just the preferred order, so you create the node list, use the preferred order rule, and have 5 buffers at each server. And with the preferred order, use the order that we came up with last, which was the fastest one first. So server 3, server 2, followed by server 1. The third configuration used the associated station overload function with no buffers, so capacity 0 buffers. The fourth configuration used associated station overload with capacity 5 buffers. And finally, the fifth configuration uses the shortest queue length and use infinite capacity buffers. And so what you should generate is a table comparing the performance metrics for the 5 configurations. Note, I'm not expecting you to use reference properties to do the comparison directly within the experiment. You can just run 5 separate experiments by changing that routing option here in the so you change the alternative routing here in the model. So you're going to update the model, run the experiment, update the model, run the experiment, and so on.